chapter, I just want to give a quick note when it comes on to debugging your job. So in case if there are issues in running your job, let's say you are not seeing the data in your destination, the first important thing is to ensure that in your input, you have data in place. Secondly, when it comes on to when you are starting the job, if you started at the current time, it might not pick up the data. You could specify a past time to ensure the data gets collected. If you are specifying the current time, ensure that you perform operations on the resource for which you're generating the logs. But also please understand that we are dependent upon the Azure platform as to when they generate the logs. See, when you came on the metrics for our Azure web app, it will generate only once the logs for the metrics per hour. Right? And we are dependent upon the Azure platform for that. You can also go on the job diagram. This gives you very useful information when it comes onto your job. I'll go on to the logical section. Here you will see kind of a chart, right, a flow of the data coming in from the input and going on to the output. You will see the input when it comes on the insights metrics. You will see the sum of the events and the bytes. If I scroll down, so I just drag the canvas here, we will see the output in terms of the metrics. We are going to go through more of terms such as the watermark delay, etc. in the monitoring section of this course. At this point in time, I just want to talk about debugging your jobs in case if they're not working. So the job diagram is very, very useful. Whenever I'm not seeing any output in the destination, I first want to make sure that I go on the job diagram to ensure that I'm actually getting events in the input itself. Now in this chapter, I want to go through the window-based functions that you have in Azure State Analytics. So as per I told you the Microsoft documentation, we have a lot of inbuilt functions in place that we can make use of. If you want to work with your datetime, if you want to work with your strings, if you want to work with your numbers, you have different functions in place, inbuilt functions if you want to add numbers. So if you want to play around with your data, you have a lot of functions in place. We want to look at the window-based functions. Now what's the purpose of these window-based functions? For this, let me first look at the data that we have been recording based on the metrics for our Azure web app. I have run this query against the table. So we saw this data coming in onto our table in the prior chapter. I'm selecting the metric name and the metric time from the web metrics table. I'm grouping by the metric name, the metric time, and also ordering it by the metric name and the metric time. See, the metrics such as, what is the CPU utilization of the Azure web app, or what is the memory of the Azure web app, all of these metrics are coming in onto our table. Why the diagnostic setting? Why the data being collected in our Azure Data Lake Gen 2 storage account? The underlying Azure platform for each and every metric is actually giving a value, right? So there'll be those values of minimum, maximum. I'm not showing it here. What I want to talk about to focus on is the time. You will see that when it comes on the metric for the average memory working set, okay, so we'll be getting the minimum, maximum, the average value every minute. You will see that every minute we are getting a record when it comes onto this particular metric. If I scroll down, the same also goes for the next metric, which is the average response time. We are only looking at about 700 rows at this point in time. But if you're collecting metrics for various resources, if you're collecting metrics for days on end, obviously, right, because you want to collect as many metrics as possible, the amount of data can actually grow very large in your table. And maybe you don't need those metrics every minute. You probably need metrics over a particular time window, a particular time frame. That's where you can actually make use of these window-based functions. So here are these windowing functions. You have something known as the tumbling window, the hopping, the sliding, the session, and the snapshot. We look at an example of the tumbling window. The remaining minutes quickly go to the concepts of the windows itself. So here the entire idea is you collect your data points across different windows. So for example, if you look at, in our case, if you're looking at the metrics, what you can do is you can actually maybe calculate the average of, let's say, the minimum metric or the maximum metric or even the average metric itself over a particular time window and only collect that data point. So instead of collecting all of the data points, you only collect the average of, let's say, a data point within that particular window. So the advantage of this is that you don't need to collect a whole lot of metrics over the nice span of time. If you don't have that requirement of collecting the metric every minute, then you can go and make use of these window-based functions. Now, in the next chapter, we are going to look at the easiest window that we have, and that is the tumbling window. So in this chapter, I want to go to the tumbling window. The tumbling window, as the definition does suggest, is you segment a data stream into different time segments and perform a function against them. If you look at the select statement, and if you're familiar with the SQL language, you will see that we need to basically use the group by clause, because see, we are grouping the data points across the window and then recording it. In the select statement, we can only use a column which is being used in the group by clause. We can use the aggregate functions, which are also available as part of Azure State Analytics. At this point in time, I'm not using the timestamp by. We'll discuss that a little bit later on. And then we have basically our stream. Here, we are specifying a tumbling window of 10 seconds in this example. What this means is that it will take all of the events every 10 seconds. What's very important about the tumbling window is the events don't overlap. This event is only going to be counted in this window. These two events are only going to be counted in this window, so on and so forth. It's not like this event is counted here and also counted in the next window. No, there is a clear segregation between each windows. This is the tumbling window. So again, the purpose of having these windows in place, I told you, let's say you only want to collect, the metrics of information over a particular time frame. Here, the example they're giving you is they want to count the number of tweets per time zone every 10 seconds. Then you can go ahead and make use of this tumbling window. So here I'm back in my Steam Analytics job. I've gone ahead and stopped the job that was running. I'm going to change now my select statement so that we can make use of the tumbling window. I don't want the minimum and maximum now. Let's say that I want to calculate the average or the average itself. I'm going to be creating kind of a different table here for collecting all of the summary information. So I'm just having now a separate table wherein I just collect the summary of the web metrics. Here I have the metric name, the metric average, and the window time. So I'm collecting the average, and then in terms of the time, so we can leave it as it is. I'll call it the window time. Then finally, I have what is the metric name. So this remains as it is. At the moment, I won't change the into and from. I first want to go ahead and test out my query. Currently, in terms of my insights metrics input, I am getting information in place. In case you're not getting the information in place, you can always go ahead and upload your sample input. Now what's next? As per the documentation, we've done our select statement. We need to group by now, both by the columns and the tumbling window. So I'll put the group by clause. We want to group by the metric name and use the tumbling window. I'll put in terms of minutes, and let's take the information every 10 minutes. Here now we're getting an error that we don't have the time column as part of our group by. What we can do is we can put the time here. We can group by the time as well. This is one way of approaching a query. Let me go ahead and test the query out. So when I run the query, I can see that I'm getting multiple values when it comes onto the time. So the memory working set, I have 2 values. I want everything to be as part of a tumbling window, right? So let's change our query. I'll use a function known as getting the max time only and remove the grouping by time here. Let me test the query. I'm not getting an error. It's saying it's not able to cast the value. See, when it comes on to the time, it's coming from our JSON input. And if you look at our JSON input, we don't have that many data types when it comes onto JSON itself. So the value for date time is actually being recognized as a string. Even though Azure Stream Antics, if I quickly again just remove the max time and put in the time here again, test the query. See, when it comes on to the time, right, it is recognizing it as of the date time format, but in the end, it is coming in as a string. That's why it's not able to use that max function. What we can do is, let me remove this time, going back here, and so we want the max of the time value. We can use another function known as cast. So if it's possible, please cast the value on to a particular type that's available in Azure Stream Antics. So I can cast it as date time and get the maximum value. And now let me test the query. Now it seems like I'm only getting the unique values for each metric name. So now we kind of have our query in place. It's coming from insights metrics, so that's fine. I'm going to create this table in my delegate SQL pool. I'll create now another output. Let's go on to outputs. Add an output. What is the table name? Add the details accordingly. So we have the web metric summary. Go on to the query. There's web metric summary. Save the query. And let me start the job. Again, we can start the job from the past. Let's wait to get the job in the running state. Now, once my job is in the running state, if I do a select star from the web metric summary, I can see that I only have 34 rows in place. This is to signify only the averages that are being collected over that time sample window, the tumbling window. Obviously, when it comes on the window, it depends upon the data points that you have in your time frames. The time is always one of the most important factors to consider when you're working with your Stream Antics job. Now, in the prior chapter, we have looked at an example on how we can use the tumbling window. What I want to go ahead and done, and just as a note, when it comes on to what is the time that you can probably record in your table. In the last chapter, we had used that max time concept. There is also another time that you can actually use, and that's the system.timestamp. So the time that we were using was the time that was recorded when the events were being sent. System.timestamp is actually the timestamp of the system clock in Azure Stream Antics. If you want to record the end of the time window, if you want to record the end of the tumbling window as the final timestamp, we can use system.timestamp over here. So as an example, what I've done is, I've modified this query. I created another table known as web metrics summary count. It again has the same column details. I then ran my job again for the events in the past. Once I had that information in place, when you look at now the window time that's being recorded here, so we have 5:10 and we have 6:10. In this chapter, we want to give a quick note on the usage of system.timestamp. Now in this chapter, I just want to go through the point where you can have multiple queries in your job. Earlier on, we had seen how we could have a job that could send data onto web metrics, let's say summary count, that particular output from insights metrics. At the same time, we also seen how we could put the metrics into the main web metrics table. We had done those jobs separately. Can we combine both of the queries within one job? The answer is yes. I have one select statement into web metrics from the insights metrics, the other one into web metrics summary count from insights metrics. I save the query. Let me go on the overview. Let me click on start job and start from a custom time. Click on the start button. If I go onto each table, I remove the data from the table, so I don't have any rows in place. Let's wait till we have the job in the running state. When my job is in the running state, I'll do a select star from web metrics. I can see the rows in place. You can see the rows have increased because I have more metrics in place. If I hit on execute here, you will see that we have indeed also got information within our web metrics summary count table. Right, so this chapter is going to go through the fact that you can have multiple queries defined within your job. Now in this chapter, I'm just going to give a quick note on a couple of other window-based functions. Please refer onto this page when it comes on the different windowing functions in RHT Annex, very important from an exam perspective. So we look at the example of the tumbling window. We also something known as the hopping window. If you look at an example of the hopping window, here it's saying that every 5 seconds, give me the count of tweets over the last 10 seconds. Hence, if you look at the window of from 5 to 10, the events will actually come in from the entire last 10-second window. If you're looking at the next 5-second interval, it's saying here, please give me the window of events over the last 10 seconds. What's happening here is you can say that, so when you have this type of window, the events can actually overlap. In the tumbling window, the events are unique to each window. They cannot overlap. So it just depends at the end of the requirement on how you want to aggregate your events. Here using the hopping window, over a particular time frame, you can get the series of events over another time frame. Then apart from the hopping window, we also have the sliding window. Here you only output the events for points in time when the context of the window actually changes. So here you can be alerted when an event occurs more, let's say, than 3 times in under 10 seconds. Here you will use the halving clause. What you can do is, I told you, you can actually go through this documentation page when it comes on the different windows. Right? It's just a change on how each window behaves in the end. Hi, welcome back. Now in this chapter, I just want to give some notes when it comes on to some important aspects from an exam perspective. The first thing is, I recommend going through this page when it comes on the common query patterns and RHT semantics. So if you scroll down, you will see sample queries when it comes on simple parse-through queries. So you're just selecting all the information into the output from the input. If you want to look at string matching, if you want to calculation over past events, a lot of examples when it comes on to the common query patterns that you have in Azure Stream Analytics. I just have a couple of queries. One query is just making use of the last function of the operator. This allows one to look up the most recent event in an event stream. So just as an example here, if you want to look at the last value of the maximum metric, not over a window but over a time duration, you can mention the limit duration here, so similar to kind of a window, so limit duration over the last 5 minutes, and then you can use the partition by to partition your data by, let's say, the metric name. So here you're taking in your data set, you're just partitioning the data set for the select statement by the metric name, so it becomes easier to go ahead and calculate what was the last maximum value over the duration of 5 minutes. If I quickly just execute this or test this out in my job, you will see the results in place. I'm just trying to give you simple examples, and all of this is based on the reference onto that page, the documentation page, when it comes on the common query patterns. The other one is, again, the query that's given in that documentation page. This is when you want to look at the difference between events as per that page. Here we are calculating what is the last window time within the tumbling window using timestamp. Now, what exactly is timestamp? For this also, you can go through the documentation when it comes on the timestamp itself. See, I told you again, time is very important. When data is being streamed from, let's say, the event hub, you would see different time metrics over there. For example, the event, when the event was processed, when the event was queued up, etc. If you want to timestamp your events via a particular time, when you have many time elements in place, then you can use the timestamp by clause. So in my example, I am using the timestamp by the time, and so within the metrics that are being recorded in my data set, there is a time column. If you want to ensure that your events are actually timestamped by the time column itself, you can go ahead and use the timestamp by clause. Don't worry, I'll be explaining this with a little bit later on, but what I'm trying to do here is we're creating a block first, trying to select what is the max time within a particular window, and then I am selecting my columns of interest, the time, the metric name, let's say the average, from my data set, again timestamped by the time. I'm doing an inner join with this particular data set over here, based on the date difference. So based on the date difference between the metrics that I'm getting here, so this is, what I do is we are trying to get the difference between the events that are coming in our data sets based on their time. So if this is a little bit confusing, just go to the page when it comes on the common query patterns. Just from the perspective of the exam, I want to give this important note to go to this page to try out the queries given here based on the lab that we've already done. So we already have data sets in place, and that's why I chose the data set in which you get metrics. Once you have metrics in your data set, you can actually go to this page and try out the different queries. So I said I want to give this important note to students when it comes on these